Okay, to pick up where we left off, we were doing unit conversions, of course, and one other thing that I haven't really shown yet is compound units. That's what you might call units that involve more than one unit, units that are made up of more than one unit. And that would be units like miles per hour, or in the SI system, meters per second, or for instance, densities like grams per milliliter. It's made up of two different units at the same time. And there are some other examples where the units might be multiplied by each other in order to get another, the unit for a different quantity. But those, we'll do those when we come to them. We'll worry about that if we have to later. For now, it's mostly going to be cases where you have 1 milliliter or 1 unit over another unit. So there are different ways to convert compound units from one set of units to another, and this is where your conversion factor sheet that I handed out on the first day comes in handy. Particularly the stuff down at the bottom that we haven't really used much yet. So for example, you notice under speed, a lot of these compound units that I mentioned, like miles per hour and meters per second, those are speeds. And you can find conversion factors in there that will allow you, in many cases, to do a conversion in one step. Whereas using just the numbers in the top parts of the table, you'd have to do it in several steps. But I'll show some of them both ways just to basically make sure that we understand what it is we're actually doing here. For something like a speed, to start out with something fairly simple, we could look at converting something like 160 miles per hour to meters per second. Whenever doing a unit conversion, and we're going to do this from the top parts of the table rather than the bottom parts. That is, we're basically just going to use unit conversions for length and mass and volume, and that'll be it. And we'll look at the speeds later, basically after we do it the hard way. So converting 160 miles per hour to meters per second. First thing I would always do in a case like this is rewrite the units as explicitly one thing divided by the other. So 160 miles per hour should be 160 miles over 1 hour. Because when you say that you're traveling 160 miles an hour, you are traveling 160 miles for every 1 hour. So I would rewrite that to that immediately. And meters per second, I would write explicitly as meters over seconds. This helps you keep track of what's in the numerator and what's in the denominator. If you write it this way, that when you're working on the problem out, you will, I can practically guarantee, miss a conversion somewhere because you'll get confused as to which one of these units is in the numerator and which is in the denominator. I do too when I write like that. Unfortunately, Microsoft Word makes it a real pain in the butt to write units like this. And so in most cases, when I type up a test or a quiz, the units, compound units like this, are going to be written like this. It's a habit that a lot of people do when they write things by hand too, because it's just easier. It keeps everything on one line. But mathematically, they should not be on the same line. It should be one thing over the other. So now realizing this, what we have to do is figure out how to convert miles per hour to meters per second. You notice that we have two units to convert. We have to convert miles to meters, and we have to convert hours to seconds. And we have to do both of those things before we're done. One thing that makes it a lot easier, though, is that we do not have to do both of those at the same time. We can convert one unit to what it should be, ignoring the other unit for the moment. And then once we've done that, we can come back and convert the other unit to what it should be. That makes it a lot easier. And then the next thing we should do is sort of plot out how we're going to get from one place to the other. So to do the conversion of miles to meters, we know that we're going to start with miles and we want to end up with meters, but how are we going to get there? Because I don't particularly remember off the top of my head how many meters there are in a mile. Maybe you do. If you do, you can do it in one step, but I don't. So looking at the conversion sheet, we're looking for things that are conversion factors between the English and metric systems, because miles is English and meters is metric. And we want them to involve units of length or distance. So that would be length here. And we have, let's see, we need miles and meters, or at least one of those two things. Centimeters, inches, no, feet, centimeters. Oh, there's meters, inches and feet. That doesn't really help. Kilometers and miles. There we go. If you can go from miles to kilometers, and using this conversion factor here, then it's really easy to go from kilometers to meters. That's just a matter of knowing what the metric prefix kilo means. And if you don't remember, it's right over here. So we have, it was, let's see, 1 kilometer is equal to 6.621 miles. And so what I'm going to do is write out a couple of steps that will convert miles to meters while leaving hours untouched on the bottom of the fraction. To do that, you just go through and do your conversions of the miles and just sort of forget about the hours for now, but they're still there. So you can't forget about them forever. You can forget about them for the moment as long as we come back and fix them later. So first conversion factor is going to be between miles and kilometers. We're going to want miles on the bottom and kilometers on the top because we want miles to cancel and we want kilometers to replace it. So we have here 1 kilometer is equal to 0.621 miles. So now you notice miles cancel. And if we wanted to stop here and write down the answer as an intermediate answer, you could do that. And it would just be in units of kilometers per hour, because those are the two units that haven't canceled out yet. But we don't want kilometers per hour, we want meters per second. So there's another step that we have to do for the numerator, and that is going from kilometers to meters. So according to the conversion table factor, or the metric prefix table here on the back, kilo means 10 to the third, or 1,000 of something. So 1 kilometer is 1,000 meters. We want kilometers to be on the bottom of the conversion factor this time because we want to get rid of kilometers and we want to end up with meters in the numerator. So it is 1 kilometer for every 1,000 meters. So 1,000 goes on top, 1 goes on the bottom. Notice that kilometers now cancels. And if you wanted to stop now and write the answer down as an intermediate answer, again, you could do that. That's okay. You'd have the weird unit of meters per hour. That's a unit that you don't see very often, but it is a speed because it's distance divided by time. At this point, we have successfully converted the unit in the numerator of the fraction to what we want it to be. So that's why I circled it, just to sort of remind me that that's what it is and that we don't need to do anything else with it. And now we can go back and fix the hours. We don't even have to start a new step for this. We can just go right on in this series of conversion factors. We know that You may know that there are 3,600 seconds in an hour. And if you do, you can do this conversion from hours to seconds in one leap, and that's good. But if you don't, then you can just go from hours to minutes to seconds. 1 hour is 60 minutes, and 1 minute is 60 seconds. So now we have to change hours to minutes. The one thing to really keep in mind here is that hours is on the bottom of the fraction. It's in the denominator. That means that that unit, in order to cancel out, has to go in the numerator of the conversion factor. So it's 1 hour over 60 minutes. Now, hours cancels with hours, and we have meters per minute if you want to take that as your answer, but we want meters per second. So there's one more step. Minutes are the units we want to convert to seconds, but again, minutes is on the bottom of the fraction, so the minutes in the conversion factor have to go on top, so it'll cancel out. It's 1 minute over 60 seconds. So now minutes cancel, and we have seconds as the unit in the denominator. Basically all done in one series of steps, and the only units that haven't canceled out yet would be meters per second. And for the answer, you just multiply or divide across, as the case may be. If the number is in the numerator, then you multiply by it. If it's in the denominator, then you divide by it. And again, you can ignore the ones because they don't change anything. So this answer would be done as 160 divided by 0.621. And I like to hit equals between each step just to avoid misunderstandings with the calculator. So that times 1,000 equals, divided by 60 equals, divided by 60 equals. And I get 71.56915, 56915,369. And that's what the calculator tells me. Now we have to do significant figures. Because obviously that's way too long. The original number that we were given, I got lazy and wrote it as 160 with no decimal point, but notice in the question, it was 160 decimal point. That means that number is 3 significant figures. The 1 is an exact number, so that would be infinite. In the next conversion factor, the 1 kilometer for every 0.621 miles, the 1 kilometer is considered an exact number, so that's infinite. But the 0.621 would be 3 significant figures. Conversion factors between English and metric, remember, are rounded off, so you do have to count significant figures for those conversion factors. Conversion factors within the metric system, though, are exact numbers, and so therefore this is infinite on top and infinite on the bottom because it's between meters and kilometers. Those are both metric units. Time conversions are normally also exact relationships. So 1 hour for every 60 minutes is infinite on the top and the bottom, and 1 minute for every 60 seconds is infinite in the numerator and the denominator also. Keep wanting to write that right side up. How's that? Infinite. So it looks like 3 significant figures it is. We have 71.5. That's 3 significant figures right there. Everything after that has to go. Notice the first number you're dropping, though, is a 6, which is greater than 5, and so that means that the last number you're keeping has to go up by 1. So this comes out to 71.6 meters per second. That would be the correct answer to the correct number of significant figures. Okay. All right, so there are many cases of things like that where we can do conversions like that with one unit over another. This is, like I said, step by step, converting one unit at a time. But as I said, there is a second way that you can do a conversion like that, and that is using the speed or velocity conversion factors on the conversion factor sheet. This basically ends up treating the compound unit as if it were one single unit. And when you do that, you can write it, for example, as meters/seconds. In fact, if you're using the speed or velocity conversion factors down toward the bottom of the conversion sheet, it usually works better if you do it this way. If you're going to convert each unit one by one, then you want to write it as one unit over the other to begin with. If you're going to use the speed or velocity conversions, then it's usually better to do it as one unit slash the other unit, because you're treating this meters per second as if it's one single unit. If you try writing it explicitly as meters over seconds, then things can get a little tight when you're writing it out, as we'll see when we actually try doing it. So in this case, you're going to have 160 miles per hour, and we're going to consider that to be in the numerator. And we'll come over here to the conversion factor sheet, and we'll see what we can find here. We've got kilometers per hour, meters per, oh, there we go, meters per second and miles per hour. And then on the second line, we've got meters per second and miles per hour. So 1 meter per second is equal to 2.237 miles per hour. So having that information, we can do this conversion in one step. So in the conversion factor, again, we want miles per hour on the bottom so that it'll cancel with miles per hour in the numerator. And we want meters per second in the numerator because that's what we want the answer to be. And the equivalent statement from the conversion factor chart tells us that there's 1 meter per second for every 2.237 miles per hour. So now you notice that miles per hour cancel with miles per hour, and we end up with meters per second as the unit. And if we take 160 divided by 2.237, we get 71.52436.299 meters per second. Again, we're limited to 3 significant figures because of the 160. This is 4 significant figures here. So 7, 1, and 5 can stay. Actually, this is a little bit different from our previous answer because the next digit is 2, which means the 5 can remain the way it is. So this rounds off to 71.5 meters per second. It was a little bit different than the answer we got the first time, but not significantly. And that's just caused in slight differences in the way the conversion factors are rounded off. Basically, this conversion factor here, 1 over 2.237, is what you get if you multiply all of these conversion factors together. And they just, obviously, they rounded it off a little bit differently than I did when I did this. So that's why the answer came out slightly differently. But it's not a significant difference. It would be correct either way. You might wonder, that's so much easier. Why didn't we just do it that way the first time? And that's because speeds are the only compound units where you have conversion factors given right here on the sheet. There are other compound units that you might have to convert, like for instance, density measurements. And those you're going to have to do one unit at a time, like we did up here, because you don't have the right conversion factor to do it all in one step. So that's why I showed you how to do it both ways. As an example of okay, let's see. As an example of a unit conversion that would involve density, I'll take the example of the chemical element osmium. It's a metal. It's one of the rarer metals in the periodic table. Its symbol is OS, if you're interested in looking it up. It's very heavy and very brittle and very stiff and not flexible. And one of the few places that osmium has ever been used, because it's really hard and really stiff, it's sometimes used in precise situations where precise non-flexible metals are required, like in parts of clocks. The most common place it was probably used, mostly in the past, was in the tip of fountain pens. So, this type of pen here that has the liquid ink that flows through and comes out the tip, at least for most of the older ones, and a lot of the newer ones too, this tip here was made of a combination of osmium and iridium, which is another chemical element that's basically pretty much right next to osmium in the periodic table. And that's why they needed really stiff, hard metals for the tips so that they wouldn't wear down as you write with them over and over again over a period of years, and also so they wouldn't bend if you press hard on the paper. Or they might bend a little bit, but they'll bend right back. So that was probably the #1 use of osmium. It's used, actually, osmium oxides are used in biology for staining tissue samples also, because osmium oxide is kind of brownish in color, and it stains biological tissues really well. Anyway, point is, density of osmium is 22.6 grams per cubic centimeter. That makes osmium the densest of all of the chemical elements. This stuff is so dense, it's about twice as dense as lead, actually. It's more dense than gold, it's more dense than iridium or any of the other elements in the periodic table. That stuff is really dense. So in other words, a small amount of it has a very large mass or a very large weight. And while 26 or 22.6 grams per cubic centimeter may not mean very much to you, if we can convert that to something that we can relate to more easily, then you might appreciate just how dense this stuff is. So for instance, let's try converting it to pounds per cubic foot. Because, a cubic foot would be like a box. I can't get it all on screen at the same time, but like a box that's 1 foot on each side. And pounds, we relate to what pounds are. So we'll see, if you had a block of osmium that was 1 foot on each side, how heavy would it be? That's essentially what we're looking at here. And as I said, there is no section for density conversions on this conversion chart. So you're going to have to convert those, units one by one in order to go from one place to the other. But I'm going to leave you with a cliffhanger because I've noticed that we've run out of time for this segment. So I'll end that there and we'll come back in a moment.